everyone, this is Mrs. Musoff here. Today we're going to talk about a special kind of case of a quadratic that we can factor called a difference of squares. And first, let's just make sure we understand what these two words refer to. Difference in math means subtraction. And when we say squares, we're talking about perfect squares. Perfect squares are numbers that can be written as a number squared. So for example, 4 can be written as 2 squared. So we would say 4 is a perfect square. Alright, some examples of perfect squares. 1, 4, 9, 16. And all I'm doing to find these is I'm saying, alright, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. And you can go on and on forever. Alright, I'm just going to list a few of these just so you get the idea. So these types of quadratics are a little different than the ones that we've seen before. So let's try to factor a few, and then maybe we'll start noticing a pattern that will make factoring easier. Alright, for example 1, notice why it's different. There's only 2 pieces. Normally, when we see a trinomial, we see 3 pieces. Well, in this case, if you notice it's the middle term that's missing. See how there's no x? All you have to do is add it in as a 0x. Alright, still have the x squared and still have the minus 9, just now there's a 0x in the middle. So when it comes to factoring, this n number, I should say, is still going to be my multiplying number. And this middle number is going to be my adding number. So if I wanted to set this up as factors, I could start by putting x's at the beginning, because it's x squared. And then I can make my list off to the side of numbers that multiply to -9. Alright, so -1 and 9, -3 and 3, or -9 and 1. And then from those numbers, I want the pair that's going to also add to 0. Well, we know when the numbers are the same, but one's positive and one's negative, that's when they add to 0. So -3 and +3. If I wanted to check just to make sure that I did this right, I could FOIL it back together, right? So let's look at that just to make sure we understand what that would look like. If I FOIL this together, I would get x times x, which is x squared, x times +3, -3 times x, and -3 times +3. If I combine like terms in the middle, 3x minus 3x is 0. I end up with x squared minus 9. Which is exactly what I started with. That's how I know I did it right. So x minus 3x plus 3 is my final answer. Alright, let's try it again with the next one. So again, only 2 terms there, and it's the middle one that's missing. That's how you know you have to add in the 0x, when it's that middle term that's missing. Alright, then my last number is still my multiplying number. And my middle number is still my adding number. I don't know why I'm doing ing here and not here, but oh well. So I'll make my list -16. That could be -1 times 16, -2 times 8, -4 times 4, and that's it. Now I could rewrite them, right? -8 times 2, -16 times 1. Just flip them around. It just changes which one's negative. Okay, and then again, I'm trying to pick the pair that's going to add to 0. Well, hopefully we can pick that pair pretty easily. So if I set up my factors, I know it'll be x and x. That's from the x squared. And I'm going to do -4 and +4. And you could use the longer way to check, or if you just wanted to check really easily, sometimes I just do my insides and my outsides. So my insides are -4x, and my outsides are +4x. And that is going to give me 0x, so I know that I did this right. Okay. One more, and then maybe we can start to notice a little pattern. Alright, so same thing here, missing middle term, so I'm going to add it in as a 0. Alright, this last number is my multiply number, and this middle number is my adding one. So I'm going to use my multiplying number and make a list. -1 times 1. Oh, there's a quick list. And then I set it up. X squared, so x and x. -1 Oh, I've only got one option, so minus 1 plus 1. Luckily, it seems like it'll work. Negative 1x, positive 1x. That is going to give me 0x. Checks out, so I know this is right. Okay. Did you notice a pattern every time we factored? Let's take a look right at the beginning. See how this number is a 9, and we ended up with 3's down here? Or how about in example 2, this was a 16, and we ended up with 4's down here? Do you know how these numbers are related? Hopefully you're saying, these are just the square roots of the numbers. And that's true. So the pattern you should notice is you're just using the square roots of the numbers. You're just using the square root. So if you notice right off the bat that it's a difference of squares, remember that means you have to have a difference, which means subtraction, and you have to have perfect squares. If you notice that both of those check off, then you can just use your square root to help you factor. Alright, so let's try it that way. Let's see, I'm going to write in one extra example here just so we could try a little harder one. So let's say, I know example 4 is here. I'm going to change that to example 5. Let's add in an example here, example 4. Okay, what if we had something like 4x squared minus 9? So if I notice that it is two terms, it's missing the middle one, instead of putting the 0x in and doing it the old way, this might be a shortcut that could help us factor it. As long as it has subtraction, check, and perfect squares. 4 is a perfect square and 9 is a perfect square. So since all those check out, if I wanted to factor this, I could actually just use this shortcut, and the shortcut says, just take the square roots of these numbers. Square root of 4x squared, that's going to be 2x. Well, that's the part that I'm going to put in the front then. Square root of 9, that's going to be 3. So that's the part that I'm going to put at the end. And as long as one is a plus and one is a minus, you have your answer. Alright, so these problems aren't so bad if you use that shortcut. Especially using the shortcut, it makes them super quick. So I like it a lot. Alright, now if you look at the new example 5 here, alright, it'd be the same kind of process. Two terms, missing the middle one. I would say, this could be that shortcut method. And I would ask myself those two questions. Is it subtraction? Well, is it? No, it's not. No subtraction. If you answer no to any of those, if it's not subtraction or it's not perfect squares, that means you can't factor it. So we would just say it is unfactorable or can't factor, whatever you prefer. Alright, so you know the pattern now. That might help you do it a little faster, but the good news is, as it says down here, if you forget the pattern, you can always factor these just like you would factor a trinomial, like we did the first few examples. You just have to remember to add that 0x in. Alright, I hope this helped. If you have any questions, write them down and ask your teacher. See ya!